What is the decimal shift? When multiplying decimals, we use place value and powers of 10 to 1. Change decimal factors into whole number factors. And 2. Determine where the decimal point is placed in a product. This video will discuss how to shift the decimal. Use the decimal shift to change this number, 34 2/10, to a whole number. To do this, determine how many decimal places are in the number. Simply count how many places to the right of the decimal point contain a digit. As you can see, the number 34 2/10 has one digit to the right of the decimal point. Because 34 2/10 has one digit to the right of the decimal point, we multiply it by 1 power of 10 to shift the decimal point, making 34 2/10 into the whole number 342. Let's practice the decimal shift with these numbers. First, 12 56/100. As you can see, 12 56/100 has 2 decimal places. We'll multiply 12 56/100 by 2 powers of 10, or 10 to the power of 2, to get a product of 1,256. Next, let's look at 87 thousandths. As you can see, 87 thousandths has 1, 2, 3 decimal places. So, to change it to a whole number, we're going to multiply 87 thousandths by 3 powers of 10, or 10 to the power of 3. This means the decimal will shift 1, 2, 3 places to make a whole number, and the whole number is 87. Last, let's look at 390 6/10. As you can see, there's only one decimal place. That means we're going to multiply 390 by only 1 power of 10 to get our whole number product, 3,906. Because we multiplied by only 1 power of 10, that means the decimal point shifted only one place to the right. So why is it helpful when multiplying decimals using the standard algorithm? Well, for one thing, we already know how to multiply whole numbers using the standard algorithm. So if you can imagine the decimal factor as a whole number, it actually makes this quite simple. So if I multiply 87 thousandths times 10 to the power of 3 to get my 3 place value shifts, I'll end up with the whole number product 87. So for 87 thousandths times 24, it's actually much simpler to multiply 87 by 24. And I get this 4-digit answer, 2088. So now what? 24 groups of 87 thousandths does not equal 2088. That product is not reasonable because we shifted the decimal point. It's time to shift it back. If 87 thousandths has 3 digits in the decimal places, 1, 2, 3, that means to shift the decimal point back, we simply divide this product, 2088, by the same power of 10, or 10 to the power of 3. By doing this, you're really just shifting in the opposite direction. And so, if we're dividing, the decimal point is shifting back 1, 2, 3 places. So the actual product of 87 thousandths times 24 is 2 88 thousandths. Let's apply the shift one more time Before I show you a shortcut, if we wanted to multiply 5 and 24 hundredths by 12 hundredths, before applying the shift, we would notice that both factors have decimals this time. Each has digits in the tenths and hundredths place. So 1 digit, 2 digits, 1 digit, 2 digits. So what does that mean? It means to get whole number factors, we're going to multiply each factor by 10 to the power of 2. When we multiply 55 and 24 hundredths by 10 to the power of 2, that means our decimal point is going to shift 2 places to the right, 1, 2, to give us 5,524. In 12 hundredths, if we multiply by 10 to the power of 2, again, the decimal point will shift 2 places to the right, 1, 2, giving us 12 as our next whole number factor. So we can imagine this multiplication as 5,524 multiplied by 12. We know this product, 66,288, is not reasonable. We have to reverse the decimal shift. In this problem, we multiplied both factors by 2 powers of 10. That's a total of 4 powers of 10. That means we have to divide the product by 4 powers of 10 to get the final answer. So if we divide 66,288 by 10 to the power of 4, that just means our decimal point will shift 4 places to the left, 1, 2, 3, 4, to give us our final answer. Again, simply shift the decimal point 4 places, or 4 powers of 10, to the left. Now let's use this shortcut to multiply 6 and 23 hundredths by 4 and 5 tenths. First, let's estimate. Since 6 and 23 hundredths is about 6, and 4 and 5 tenths is about 5, we can reasonably estimate the product will be about 30. So the first thing I noticed is that there are a total of 3 decimal places in these factors. 1, 2, 3. Remember that when we shift the decimal at the end. So I've shifted my decimal to get the factors 623 and 40. You'll notice that I've applied the decimal shift before I multiplied. I'm just going to proceed as if there are no decimal places. So 623 times 45 gives us a product of 28,035. Now, shift the decimal point in the product to the left 3 places to compensate for the 3 decimal places in the factor. Remember, there were 1, 2, 3 decimal places in our 2 original factors. Here's that 3 decimal place compensation, 1, 2, 3. Our final product is 28 and 35 thousandths. Try some problems on your own using this strategy. In this problem, you can see the problem is set up using the decimal places, but multiplication is carried out as if there were no decimal places in the factors. In the end, because there were 2 decimal places, we compensate in the product for 2 decimal places by shifting the decimal point 2 places.